so now we're going to go to question 4, and question 4 is really just a variation of question 3 because it's asking us again about marital status and asking us about BMI. But the difference here is that we're now comparing between people who have never married, which is what we did last time, okay, and we're comparing those to now two different groups of people, people who are either married and the spouse is in the household, or they're living with a partner. So clearly, in looking at our data, we must have thought, you know, these people are probably pretty similar, so let's compare anybody who answered yes to any of these questions to this group. So what we have to do first that's different is we have to recode a variable into a new variable so that we can then compare these two categories of people. Okay, so what we're going to do is we're going to go over to SPSS, and let's go to the data file, and what we're going to do is we're going to look at marital status, and let's look at that again so that we can find out which groups we need. Okay, so we need the people who are a 1, married and spouse in the household, right? We need those people and the people who are an 8 to be compared to the people who are a 7. Okay, so the 1s and the 8s compared to the people who are a 7. Okay, so this is really nice. What we're going to do is we're going to transform, and we're going to recode into a different variable. And the reason we're using a different variable is because we don't want to blow away our variable that we've called marital. So we're going to recode into a different variable, and we're going to take marital, and we're going to recode it into a new variable that we can just call, we can call whatever we want, but we'll call it marital 2. All right? And then we're going to do old and new values, and we're going to say if our old value was a 1, let's keep it a 1. All right? And we're going to add that. If our old value was an 8, let's make it a 1. Okay, so these are married people with a spouse in the household, or, married people with a spouse in the household or living with a partner. And we're going to compare them to the people who are never married. I hope I'm doing this right. That value is going to be a 2. All right, I better just check this. The tricky thing is I can't check it. I should have written it down. So I made the 1s and 8s a 1 and the 7s a 2. So if I go back here, I can do my change, and that's going to push that marital 2 over here. Did that make sense? Before I clicked marital 2, it wasn't over here, but when I click change, that puts it over here. Prior to clicking change, I couldn't have hit paste. Okay, so I'm going to hit paste, and actually this is good because I'm using paste. I can double check that I got things right before I actually run it. So 1 is spouse in the household, 8 is living with partner, so that was right. I made the 1s and 8s a 1, and 7 is never married. So now I'll go to my syntax window. I'm going to highlight this recode command. It's going to recode, and then what you'll see is when we go over to our data window, if we go all the way out to the end, it will have created a new variable for us called marital 2. And there's lots of blank spaces because those are people who didn't have a value of 1, 7, or 8. Okay, we don't need those people for this particular comparison. But now we have a variable that has 1s and 2s, and if you remember, we can give the values a code which would be sent. Makes sense. So this is either living with partner or spouse. We'll add that, and then if it's a 2, it's never married. Okay, add that, hit OK, and now we've got those values for us. All right. So now what we want to do, of course, is just an independent samples t-test again, so you should be comfortable with this. We'll go to independent samples t-test. It's the same questions we had before, but now instead of using marital and the 7 and the 8, we're going to use marital 2, and we're going to compare the 1s and the 2s. Paste that, go to our syntax window, highlight it, and run it. And now we're down here at the bottom of our screen, our last t-test. Here's living with partner or spouse, the numbers, the means, the standard deviation. And here's what we're most interested in, the results of the t-test. We look here first. We see that that's greater than 0.05. So we're going to fail to reject the null hypothesis, which means that we can assume that there is no difference between the variance of the two groups. That means we get to use this row, and we'll use this data for the t-test. Okay, so now we're going to look here to see, okay, now, so, and again, I guess I haven't said this, but this is the test, these two boxes are the test for equality of variance. This is all the information that relates to the t-test for the equality of means. So this t-test data is what tells us whether the means are the same or not. And you can see right here when you look at this value that the significance is less than 0.05. Our alpha criterion is 0.05, that's like our critical value for the probability, and we're less than that. So that means that there is a significant difference between these two means. You can see it's not a very big difference. What's driving this and making this come out significant is largely that these sample sizes are just so big. So we can write this up, right? There is not a statistically significant difference between people who have never married. I kind of like doing it this way now that I started doing it, so I go ahead and just type in these means. Oh, and you guys, surely you caught me, right? There is a statistically significant difference between people who have never married, and their mean is 29.50. Standard deviation is 13.70, and those who either live with a partner or spouse, and their mean is 30.53. Standard deviation equals 14.64, and then we put t with 3,568 degrees of freedom equals 2.02, p less than 0.05, two-tailed test. Right, and that's it for that one. So now let's go on to the fifth one. You guys are ready for this. The fifth one is, what test would you use to see if there's a difference in minutes of physical activity as a function of intensity level of the activity? And then it lists two variable names. So when we go back to our SPSS window, let's just look at it this way and look for those variable names. So we are looking for VigMin, which is right here, and ModMin, which is right here. So these are, if you look over here, the duration of vigorous activity in minutes for a given person, and the same thing, the duration of light to moderate activity in minutes for a given person. And you can see here that there's a coding for people who either refuse to answer, it wasn't ascertained, or they don't know. And what's interesting is, and one of your colleagues pointed this out to me, is that, see under here where it says missing values, those should be listed as missing values, otherwise they get included in the calculations, and that doesn't make sense. We wouldn't want a 997, a 998, and a 999 included in the calculations. So we should go ahead here and add discrete missing values and tell it, this is good, this came up, that those are the missing values that we don't want included in our calculations. And I bet the same thing's true for vigorous minutes, yes. So we'll put 997, 998, 999. So again, that's because they've used that coding. If we go look, they've used that coding to mean that it's missing data, or the person refused to answer, or whatever it might be. And so we could expect that maybe in this column we might see somebody who has a 900 and something data point. I don't really want to scroll through all 5,000. But anyway, there could be somebody in here who put in a 997 to mean, I don't know, or I refuse to answer. We don't want that included in our calculations. That wouldn't make sense. Okay, so now, this test is the first one we've had that is actually a dependent samples t-test. And the reason it's a dependent samples t-test is because we've got this information about minutes of physical activity at these different intensity levels for the same people. So I've got moderate minutes and I've got vigorous minutes for the same person, you know, going across this way. I've got 180, subject number 1 here has 180 vigorous minutes, 120 moderate minutes. So I've got data on the same people. So it's under Analyze again, go to Compare Means. Here they call it a paired samples t-test, but that should make sense to you. It's a dependent samples t-test, or paired samples. And this one looks a little bit different because what you're asked to do is to identify, you could do more than one pair at a time, but you identify the two variables that you're comparing. So we need to scroll down and fix this so I can see until we find VigMin and ModMin. Here's ModMin. Doesn't matter which one goes in first. And here's VigMin. So we shoot that in, and then we're going to paste that. Now we'll go to our syntax window, and we're going to run this calculation. So this is one we haven't looked at before, so the output looks slightly different. You can see here, this part really looks familiar by now, so they've got just the descriptive data for duration of light moderate activity or mod minutes, and then vigorous minutes, same number of people, which makes sense, right, because it's paired data, and then here's the standard deviation. This tells us what the correlation is between these variables, and that's something that we'll be working on in the future, so I'm going to ignore that for right now. And then this is the paired samples test, and you can see here it's got the paired differences, so this is the data that relates to that. This mean, this is the average difference between the scores, so this is actually the mean of the different scores. You know, when you think about making that column of different scores, that's the mean of that column. Here's its standard deviation, standard error. And then, of course, where we're going to be looking is out here where we have a t, a degrees of freedom, and a significance. So when we look at these, oops, okay, I'm not doing this right. When we look at these, and I'll go ahead and highlight them so you can see them really well, we see that the significance is less than 0.05. Okay, so it's less than our alpha criterion of 0.05. That means it is a significant difference. Here's our t-value, and our degrees of freedom, you can see, is we had 1,663 pairs of scores. So we have 1,663 subjects. They each have 2 scores. You take the number of different scores minus 1, so that's why that's 1,662. Okay, so now we can write up this result, and we say that there is a, can't really see that, there is a significant difference in minutes of physical activity depending on intensity level. T with 1662 degrees of freedom equals negative 5.65, p less than 0.001, such that participants reported, and let's see what the means look like. They reported more vigorous exercise, mean equals 53.39, SD equals 40.02, then moderate. Actually, it was actually light. It's called mod-min, but it's actually light to moderate intensity exercise. Mean equals 46.32. Standard deviation equals 46.88. You can see I'm getting those numbers from this table here. And if you want to be complete, it would be great if you took the time to highlight these cells as well. That'll help me if I find any problems in your assignment, and it'll also help you if you go to look back at this sometime in the future. Alright, so that's it. You guys are now masters of the t-test. You can do independent samples t-test, you can do single samples t-test, and you can use dependent samples t-test. Great job. Save this somewhere so you have it, and then when you're ready, go on to assignment number 2.